If we're going to derive the derivatives of sine and cosine using the limit definition of the derivative, we're going to need two more things, and that's the sum formulas for sine and for cosine. We'll need this one for the derivative of sine. We'll need this one for the derivative of cosine. Now, these are formulas that you've learned in the past and may or may not remember. I'm going to teach you a nifty mnemonic device for remembering these, and I'm going to encourage you to be familiar with these. But I'll also be honest, we're really only going to need these sum formulas once this semester, and that's in deriving these derivative formulas. So, I'm not going to hold you responsible for having them memorized this semester. If you need to use them on an exam or a quiz, I would provide them for you. However, I know a lot of you are planning to go on to 3B, second semester calculus next semester. Then these formulas become more important because these formulas lead to the double angle formulas, which get used a lot in second semester calculus. So I'd suggest that you memorize them now, and you can memorize them by thinking of this mnemonic device. It's very rare that I say memorize something. Usually I like to figure things out and understand them, but these are pretty useful, and I love this mnemonic device. I wish I could take credit for this. I can't. It was a former student of mine named Cindy who came up with this. I don't remember her last name, but she came up with this, and it's brilliant. It all comes down, you see, to the psychology of the trig functions. Sines, which starts with an S, are very social also starts with an S, very social functions. So when sines are in charge of a party, you'll see them mixing it up and talking to the other trig functions. Very social of them, and that's a very positive quality indeed. Okay. Cosines, on the other hand, very antisocial functions. So when cosines are in charge of the party, they will only talk to the other cosines. Of course, that leaves the poor sines with nobody to talk to but the other sines. Not only that, the selfish bastards put themselves first. And that is a very negative quality indeed. All right, so those are the sum formulas for sine and for cosine. Okay, again, we'll use the one for sine. Now, as we find the derivative of sine, we'll use the one for cosine when we calculate that derivative. So what I want to do right now is I want to actually calculate the derivative of sine. We've made an educated guess based on what its graph looks like that it might be cosine, but we want to see. So I always like to have a picture. So here's my sine function. I'm going to have a point x sine x, and then we'll have a nearby point x plus h sine of x plus h. So notice that sine evaluated at a sum. Instead of a plus b, it's x plus h, but that's where we're going to need to use that sum formula. So there's our secant line, and so this is just the limit as h goes to 0 of sine evaluated at x plus h minus sine of x all over the run is just h. To simplify this, I'm going to use the sum formula for sine. So this is the limit as h goes to 0, and I've just got x and h in the roles that a and b were in the statement of the formula. So sines are the social ones, so we'll have sine of x talking to cosine of h, they're just hanging out at the punch bowl, plus, because being social is a very positive quality, cosine of x talking to sine of h. That's my sine of x plus h. Now we're going to subtract from that sine of x, and then that's all over h. So now I've got 3 terms on top, and this very first one and this very last one have something in common. They both contain a sine. So I'm going to just switch the order of these last 2 terms to put the 2 that have something in common together. So we've got the limit as h goes to 0 of sine x cosine h minus sine x plus cosine x sine h all over h. And now, even though it's 3 terms that we have on top, I'm really going to think of it as 2 groups. there's this group from which I'm about to factor out a sine x, and then this extra term here. So we can say we've got the limit as h goes to 0. From this first group, I'm going to factor out the sine x. So that's sine x times cosine h minus 1 plus cosine x times sine h. And it's all over h. And then I'm going to just distribute the division by h. So I'm going to say this is the limit as h goes to 0 of sine x times cosine h minus 1 over h plus cosine x times sine h over h. And now each of these fractions involves a product on the top. And one of the factors has an h in it, and the other one doesn't. I'm just going to rewrite that, separating out the factor that doesn't have any h's. So I'm going to say this is the limit as h goes to 0 of sine x is multiplied by cosine of h minus 1 over h plus cosine of x is multiplied by sine h over h. So in my fractions, I kept the pieces that had h's together in that fraction, and I just sort of slid the sine x or the cosine x off to the side. So now we've got 1, 2, 3, 4 pieces that are connected with arithmetic. We're multiplying and we're adding. I can use my limit laws to break this up and evaluate each of those 4 limits and then do the arithmetic. I can do that provided that each limit is a finite number. So I can say this is the limit as h goes to 0 of sine x times the limit as h goes to 0 of cosine of h minus 1 over h plus the limit as h goes to 0 of cosine of x times the limit as h goes to 0 of sine h over h. So now I want to evaluate each of these things. Now here I'm taking the limit as h goes to 0 of sine x. There are no h's in that. Sine of x is constant with respect to h. Remember what that means graphically. This was my point of tangency. It's not moving. X and sine of x are representing fixed but unspecified numbers. What's changing is the location of that second point. So this first limit is just sine of x. That's going to get multiplied by this. Now that should look familiar, but I'm going to do a little bit of side work up here. We had derived that the limit as h goes to 0 of 1 minus cosine of h over h was equal to 0. We actually derived it with x's. I'm just writing it in terms of h now. Notice what we have here is actually the opposite of that because we've switched the order of the subtraction problems. So I can say the limit as h goes to 0 of cosine h minus 1 over h. That's just the limit as h goes to 0 of negative 1 times 1 minus cosine h over h. If I factor out a negative 1, that makes the cosine negative and the 1 positive. But then that's just a constant multiple of this thing. So what we're going to get is just negative 1 times 0, which is 0. So with subtraction, order generally makes a difference. But here, well, I get the limit is 0. When I change the order of subtraction, I'm going to get the opposite limit. But the opposite of 0 is just 0. Okay. And I actually don't expect you to remember that that's the one we derived. You may use as a known fact, unless I ask you to derive it again, that this limit is 0 and that this limit is 0. that because the limit is 0, the order of subtraction doesn't actually affect the value of the limit. Okay. That's in general not true, because 0 is the only number that's its own opposite. But when the limit is 0, getting the opposite result still gives you 0. So this limit here is 0 plus the limit as h goes to 0 of cosine of x. I don't see any h's in here. If x is representing a constant, then cosine of x is representing a constant as well. So this limit is cosine of x. Limit as h goes to 0 of sine h over h. That's just 1. Sine of x times 0 is 0. Cosine of x times 1 is cosine of x. The derivative of sine x is cosine x. So the educated guess that we made based on the graph was correct. Very cool. Now, a lot of times what happens is students will say, oh, the derivative of sine is cosine. So it must be that the derivative of cosine is sine. There must be a pattern. Well, of course there's a pattern. But one example doesn't establish that pattern. Okay? So we can't yet jump to that, and that would in fact be a wrong conclusion. What I want you to do before watching the next video is sketch cosine of x for me, and then sketch its derivative. You should see there's no way that the derivative of cosine could be sine, but you should be able to make an educated guess based on the graph. So I want you to do that before you tune in to the next video, and then we'll walk through that together in the next video.